Yes. Now we will discuss what is electric current. Before that, we know that in any conductor, say I am considering electric material which is of conductor type. Okay. In this I have atoms, and in between these I will have electrons, the free electrons. Okay. And these free electrons will move randomly, because why these electrons will move randomly? We know that similar charges repel, right? That's why these both charges will be repel each other and move randomly. So charges move randomly. Okay. Then the direction of the charge moving, if we consider in this direction, some charge will move, and opposite direction also the same amount of charge will be moved. So the net amount of charge flow, that means charge flow will be is 0. Okay. This is under no bias. Under, we can say that under no bias. No bias means under no external supply. Right? What happens if we apply any external influence? For suppose this is an electrical material, for suppose it is a conductor. So in this I have electrons. Okay. Whenever I apply something, a forcive element here, say that is some voltage. Okay. If I apply some voltage, there will be a flow of electrons, flow of charge, right? Flow of charge. If we apply force in this direction, they will flow in this direction, right? So flow of charge in a particular direction. And I can say simply in a formal way the directed flow. Okay, that means which has direction. So the directed flow of charge, is current. That means how can we measure the flow? How can we measure? The flow will be measured with respect to time. How much of charge is flow? That's why the rate of charge is current. Okay. The rate of charge is current, and that can be formally or mathematically we can represent current equal to rate of change of charge, right? if you want to write, that can be something like I equal to Q by T. And what is the unit for the current? Amp. Or this is Q can be expressed in coulombs per second. Okay, so that's why it is called as 1 amp equal to 1 coulomb per second. This is the story behind the current. And what is the direction of the current? That we have to discuss. For suppose I have a conductor like this, okay, and if I apply voltage externally, it is a plus and it is minus, so the electrons present inside the conductor will be flow from externally towards the positive side. The electrons direction will be in this direction, but the current conventional way, internationally approved or internationally authorized standard convention, is opposite to electrons flow. So that's why the direction of the current will be like this. Okay, this red colored line will represent the direction of electrons, but this yellow line will represent direction of current, and that can be formally represented as conventional direction. Okay, conventional direction. So this is current. Shall we do one problem based on this? Okay, the problem is ten coulombs of charge is flowing through a conductor for 2 minutes. Okay, then what is current? What is current? This is the question. If you observe clearly, what are all the things given here? Q is 10 coulombs and T is 2 minutes. But our standard equation will be I equal to Q by C coulombs per Q by T, coulombs per second. The time is expressed in seconds. That's why we will change this into seconds. 1 minute equal to 60 seconds. That's why that will become 120 seconds. Okay. Now I equal to Q is 10 coulombs, 120 seconds, and that equal to 1 by 12 amps. Okay.